Building the pyramids found. Building the pyramids found shows Egyptian construction techniques found through trial. These techniques may be early inventions for the construction of the pyramids of Egypt, a lost method of moving millions of blocks up ramp. They may also be new original ideas. Either way, in my mind, they provide a simple way solving how the pyramids could have been constructed.
Hi! The construction of the pyramids have always been a mystery. The series focuses on the Great Pyramid, showing how all the other pyramids at Giza may have been built, demonstrating that man built them and not aliens. They show that ancient Egyptians could have transported the blocks to site and also get them to the top of the Great Pyramid. In this part, I see if it's feasible to all the large stone blocks to construct the Queen's Chamber, the Grand Gallery, the King's Chamber and the relieving chambers above. This pyramid theory isn't high technology, it's based on simple engineering techniques using rollers on ramps, but with a difference. It may be technology found, so without saying any more, let's get on with the video, and don't forget to give it a like, subscribe and please comment.
Music, Sean Plowman, stroke Shedman.
Praetor's theory. Bedroom models. Building the pyramids found. Part 1. Hi, my name's Michael Praetor. In the past I've helped on a number of construction projects in a few countries, mainly involved in civils. But today I'm here to show you ways to elevate large blocks and ease the stigma surrounding the difficulties in building such large structures. I wasn't born an entertainer, so in that regards the video is going to be pretty poor.
Diabolical.
But what I can give is the best method so far to construct the Great Pyramid, without doubt. So keep watching.
I can't say it was built like this or that, as I wasn't there at the time.
Obviously, can't explain it all in such a short video. If it doesn't answer all your questions, you may have to refer to the book, which has far more in it than I can show you. Behind me, or should I say below me, is how I'm going to do it.
I will show a few inclines and use what I call an A-frame to get the blocks up on rollers. I will test these methods to see if it's possible to haul the blocks of varying weights up such inclines and reach a height plausible to construct the pyramid. The test I will carry out will involve gravity to demonstrate how many men it would take to haul blocks of varying weights up the pyramids to complete it. I have designed basic equipment that could have been used at the time to make the job a lot easier for the men.
Some of you probably know that the use of rollers have been ruled out by most people. This is because the sledge or block moving over it has a tendency to go offline. I will show you basic methods never seen or thought about before. Saying that, these ideas may have also long been forgotten. These ideas are really basic, so I would say the latter. So with all the comments I've been making, and like I said, I'll show you the best methods so far to construct the Great Pyramid, I think I better get on with it.
The models you're about to see are as rough as gauze. They've been made mainly from recycled materials and look like it. I excuse the poor workmanship, as I only made them to demonstrate to myself and never expected to be displaying them. Rollers.
I have to start with the rollers. As you can see, there's strings tied to their ends. This keeps the rollers in line. The idea is as basic as that. Not as basic as that. You also need the equipment to go with the guide rollers to make the package. Rollers are placed on timber rails. This provides a smooth surface to roll over.
Rails also help spread the load.
And this set of rollers are tied to prevent the block flying off the end.
If we took the pyramids, with millions of blocks involved, you would need a permanent and semi-permanent site system for the job. You wouldn't want to keep taking rollers from the rear and then have to place the rollers in front, while also have a few more guys trying to keep the sledge block in line. Imagine trying to put logs in front of a sledge on a slope.
This set of rollers are a little bit different, but they basically do the same job and give similar results.
The best thing of all is they all return to the starting positions by themselves. How consistent, how convenient. Other than the maintenance, where are the men?
That's for the rollers.
The A-frame.
Okay, this is the A-frame.
These are what are called the guide ropes. In this instance, there is only one set tied from the spool to the frame. It should have guide ropes really on both ends to prevent slippage. Ropes also loops around the ends of the spools at either side. More than one rope could be used from the spool to the sledge, but a piece of string gives us a basic concept. The frame provides clearance for the blocks to pass underneath the spools. Blocks can pass through the frame or travel 90 degrees to it. The rig could overhang the outer face of the pyramid, passing blocks from it along the walls. The rising of the spool nearest to the ramp provides a bit of lift on the load being brought up. More importantly is the weight on this spool from the load. This prevents the A-frame from being lifted off the floor. Just like you would expect for moving large blocks, A-frames are heavy large pieces of equipment.
Especially if you fall from the building.
Surprisingly enough, the A-frame could overhang the building by more than 1/3 of its base size without tipping over. As you can see here, you can create different rigs in size or gradient to suit the purpose of the task. There are various ways to raise the frame upwards, such as lifting using another rig or two, which have guide ropes. If everything was scaled up, the A-frame would be able to pull more than 58 metres, around 190 feet, without having to reset the spools to the starting points. The rope could just rest on top of the spools like it is in this case. The sledge blocks could be held on the ramps, loosening the ropes, while the spools are returned to the starting positions to go again. Anyhow, the good thing about the A-frame, the spools counterbalance each other. As one goes up, the other one goes down. Because of this, very little physical effort is needed to get the spools back to the starting positions. A-frame, good. This image shows the weights of stones required at various heights in the Great Pyramid. Stones above the King's Chamber are said to weigh 70 tonnes, and some say they could weigh around 90 tonnes, but I'm going to use a figure of 100 tonnes. My job is to see if it's possible to get these weights to the required heights.
Sorry about the maths in this bit, but I have to explain how the pyramids could have been constructed and how it is possible to move the blocks for the Grand Gallery, the King's Chamber, the Queen's Chamber and the Relieving Chamber. How the pyramids was constructed practically is probably the reason why you clicked on this video. So if you'd like to find out, keep watching and don't forget to leave your comments, because I'd love to hear your comments and views on this interesting subject.
2 degrees. On the 2-degree ramp is a sledge with a couple of small concrete blocks taped to it. If it was scaled up in my model world, it would weigh 13 tonnes.
But it doesn't.
Let's pretend it's a theory after all. If the pretend sledge weighed 13 tonnes, the smaller blocks would weigh 1.75 tonnes. I have done this before, dropping 1.25 tonnes and less, but because this ramp is used for some of the largest blocks in the pyramid, I've gone with what you just seen. $1.75 tonnes for 13 tonnes equates to a ratio of 7.42. Just to explain, the ratio in this case is used to uniformly scale the 13 tonnes up to 100 tonnes. So don't get bogged up with the mass. Just look at the blocks on the right hand side and compare them to the blocks on the left and what you've seen from the earlier test or test to come. But to make this easier to understand, it is said that the average man can insert a force on a rope anywhere between 100 kg and 200 kg. If we had 4 men on a sledge each weighing 150 kg and it takes one man pulling 150 kg, to find the ratio you would divide the load by the pulling force. This would mean this particular incline would have a ratio of 4. If there was 8 men sat on the sledge, it would take 2 men to bring the guys up. The ratio does not change for any weight brought up on the slope. If the incline was steeper, then it would take more men to pull the guys up, and therefore the ramp ratio would then change. If the guy on the right hand side just dangled off the side, he would be able to bring up the 4 guys on the sledge, because he weighs 150 kilograms, and therefore inserting the same force on the rope. Okay, back to the 2-degree ramp. 1.75 tonnes would equate to 12 men pulling on a rope. Each of these men pulling 0.15 tonnes or 150 kg. So theoretically, to pull a 100-ton block up the ramp would take a pulling force of 13.47 tonnes, this requiring 90 men. All the time when making the models, I kept on thinking of what I call the fly on the wall syndrome. In other words, if the fly was scaled up, it would just fall from the wall. So how would the rollers perform if everything was scaled up? When testing the 26-degree slope, I did increase the weights to 5 times the amounts. The results were the same. A 2-degree ramp is relatively flat. The rollers may suffer more friction than the model. Add to that the weight on the rope on the guys pulling. Because of this, I have double the force needed to move a 100-ton block. This now involves 180 men, 90 men on either side of the rollers. Men could be on the ramp spaced at 750mm, roughly 2.5 feet in front and behind, less body width, requiring a length of 67.5 metres, around 221 feet. Is there enough room for these men? Can the pitch of the ramp gain enough height to place the block? Is it possible to get 100 tonnes to this height? In my opinion, yes.
Since making this video, I've carried out tests with life-size equipment, which makes me believe the ancient Egyptians could have easily have completed the Great Pyramid within the 25-year time period as suggested. You can see this for yourself in the following videos. Anyway, that's it from me. Comment and thanks for watching.